So in the textbook, it talks a little bit about the gray wolf and what's happened over the years. And apparently, like in the 1800s, early 1900s, a lot of gray wolves were killed because, probably the farmers didn't want them eating their chickens or, getting into the crops or whatever. Anyway, so the population of the gray wolf went way down. I think it said like around 800, like in the 60s or something. Anyway, so they did things so that we could get the population of gray wolves back. And they established like programs to because it was an endangered species type thing. Okay, so they did two like reserves for the gray wolves, and there was one in the north, Rocky Mountains, and one in the western Great Lakes. Okay, so we have data there, and we're going to need that data a little bit later. Okay, so most models for populations are exponential. And I wish that little thing weren't there. I'm having trouble with my computer. Okay, sorry. Okay, so it says the exponential function, and it's right there's our exponential function, models the gray wolf population of the western Great Lakes, f of x. F of x tells us the population. Okay, so when we're doing these functions and we're working, we have to know what it's talking about. Like, what is the function representing? What is the output? The output is the population. Okay, you can see the E in there. That's exciting because we just learned about E. And then the X is the number years after 1978. So the X is going to be a year after, I'm sorry, 1978. Now that's important. So a lot of these models, especially population models and other models, they'll say, okay, at a certain point, the exponential model kicks in, and so we want to go to that point. Okay, so according to the model, this is part A. You can't see my A, but there's an A. Okay, according to the model, what was the gray wolf population rounded to the nearest whole number? So we don't want part of a wolf, but of the Western Great Lakes in 2018. Okay, so here's the model we have. F of x equals 1144 e to the 0.0325. That number is really important. X. Okay, so we're going to we got to figure out what X is. Okay, so we're going 2018. How many years after 1978 is that? So you have to take 2018 and subtract the 1978. And you should get 40. Okay, so X is 40. That's our X value. We're saying 40 years after, or 40 years into the recovery program, how many wolves are there going to be? So we're trying to find F of 40. We're trying to find the population, and this model is going to help us. It just predicts it. Okay, now you need parentheses up here. So 0.0325 times 40. Okay, so when we put this in our calculator, that's going to be important how we put that in. Otherwise, you're going to get really different numbers. Okay, so 1144. And then I'm going to hit my e to the x button. Okay, I'm going to put in 1144. Let me clear this out. 1144. And then let me get my e button. It'll show on my display. So I have the E to the little, the little mountain, and it opened a parenthesis for me. Now, if your calculator doesn't open a parenthesis, you got to put one in. Okay, so I hit the E to the X button and I get a parenthesis. So you may have to put this, or it may already be there. May already be there. Like if you're trying to follow these steps. Okay, and then I'm going to put 0.0325, make sure you get the decimal in there, times 40, and then I'm going to close that off. Okay, so I've got my parenthesis, 0.0325 times 40. And I'm closing that off, hitting the equal, or the enter button, whatever it says, and I'm getting, it's 4197.675, and then there's some more things. Okay, so is it going to round up? The answer is yes. So I'm saying 4,198. That's how many wolves I think there's going to be in 2018. Okay. Part B says Does the model underestimate or overestimate the gray wolf population? So apparently they went out and counted the gray wolves or something. Anyway, we have data on that. And then they want to know by how much. Okay, so is our model bigger or smaller than, they probably didn't count the wolves. They probably used other methods, but let's see. It says for the Western Great Lakes, it was 4,222. Okay, so the data says 4,222 wolves. The model says that we just did 4,198. So it looks like the model underestimates by, and then we have to figure out the difference. So we're subtracting. I'm just going to do it on a calculator. Saturday, I don't want to do too much thinking. And I get 24. So it underestimates by 24 wolves. Okay, and that was part B then. So part A, our prediction was 4,198. Looks like we're a little under by 24 wolves.